Okay, so I'm going to go over 2.1 RSG number 14 and 15. So it says create a graph to model the statement and then label the X and Y axes appropriately, and then be sure that your graph correctly represents whether or not the situation is continuous or discrete. Okay, so it says approximately 3.24 billions of gallons of water flow over Niagara Falls daily. Okay, so they just want you to graph this, right? So let me go grab a graph. Okay, and let me go here. Okay, so it says, make sure you correctly label the X and Y axes and be sure that your graph represents the situation is continuous or discrete. Okay, so the very first thing that I want to do is I want to label my axes. And so if this is 3.24 gallons of water a day, then that means this is going to be days and this is going to be billions of gallons. Okay, billions of gallons. Okay, and if you notice, the way they stated this is the slope of your line, right? So of a line, this is going to be your slope. So it's 3. So whenever you're thinking about slope of a line, it's y equals mx plus b, and slope is your m. So here I'm looking for what my m is, and they just gave it to me. It's 3.24. So I'm going to write 3.24 times x plus b. Now b is my y-intercept. Now that is like on day 0, how many billions of gallons of water flowed then? And it's 0 because none of them had flowed yet, right? So this is actually my picture. And then they want to know if it's continuous or discrete. And so remembering that discrete means that the points are not connected and continuous is. Now this function that I've graphed is continuous, but I want to know, does it make sense for us to connect the points for this context? So the questions that you really want to ask yourself is this: can you have half of a day? Because this is days. Let me just snip this really quick so I can write all over it. Can I have half of a day? And you'd say, yeah, you can have half of a day. And I'd say, okay, well, I'll take that. Let me make this smaller. So here, right, this is going to be days, right? And this is going to be, this is billions. And then this is water. Oh no, I moved it. I moved it and I didn't. I forgot that I moved it. Sorry, let me grab this, put it here, and then I'll wait for that to go. So this is in billion, this is water, how much water flows over the Niagara in billions of gallons, right? So let me just take that and move it. Oh, it's both moving. There you go. Okay, so I want to know, does it make sense for us to connect these dots? And the answer for this one is yes. It makes sense because I want to ask you, can this point right here, I don't know, whatever that point is, it looks like it's 0.5 comma, what would that be? Let's bring our equation back here. If I plugged in 0.5 here, 0.5, right? That would be 1.62. Okay, so if I wrote, hey, this point is half of a day, comma, 1.62 billions of gallons of water, would you look at me like I was like, what? Or would that make sense? And yeah, that makes sense. Why does that make sense? Because we can have billions. Oops, I was going to move it again. We can have billions. We can have 1.62 billions of gallons of water, and we can have half a day. That makes sense, right? Okay, so number 15, the average person laughs 15 times per day. The average person laughs 15 times per day. Okay, so again, this looks like a linear context, right? So I'm going to bring this guy back. And of course, I'm going to use y equals mx plus b. And our slope in this case is 15. Okay, so I am going to snap this again. And then the question is do I connect the dots? That's the question. Do I connect the dots? So let's see, would it make sense for you, okay, doing this again, right? I'm going to label my axes. So this is going to be in days. And then this is going to be in laughs, right? So would it make sense for a half a days of laughs? Yeah, you can measure half of a day. Sure, no problem. Okay, but in terms of number of laughs, like what does half of a laugh look like or sound like, right? So in this context, it shouldn't be continuous. It should just be discrete, right? It has to be discrete because there's no such thing as half of a laugh. And I'll write that because half of a laugh doesn't make sense. Okay. What else? What other kinds of contexts don't make sense? Well, my classic context is like there's 100 students that are going on a field trip. There's 3 buses. How many students on each bus? And you're like, oh, Ms. Johnson, I know how to do this. I take out my handy dandy calculator and I go 100 divided by 3. And you're like, oh, it's 33.3. Well, if you think about the context of that, you're not going to put 33 and a third of a kid on each bus, right? You're going to put 33 kids or you're going to put 34. You're not going to put 33 and a third. That's gross, right? Okay. So again, continuous means that I have to connect the dots. So if I was to actually graph that over here, right, it would look something like this, where this is days and this is laughs, right? Sorry, it's hard to draw straight lines on my iPad here. So if I had one day, I'd have 15 laughs. I'm going to pretend each one goes by 5 here. So this is 1. So then this is 5, 10, 15, right? If there was 2 days, then that would be 30. 3 days, that would be 45. Here, I'm not connecting the dots because half a laugh doesn't make sense. Okay.